All right, so that 5-minute timer is up. Let's take a look at the warm-up. And the first question is to complete the square to form a perfect square trinomial. So we want to add a term here such that this will turn it into a trinomial that's a perfect square. And I have 4 responses for if you tried this or started writing on it. This person here actually has the correct answers. So B is the term. You look at the x term and you look at the coefficient. So since 26 is right here, we're going to take that, divide it by 2, and then we're going to take that answer and square it. And so we're going to add 169 to this binomial, and that turns it into a perfect square trinomial. And so this can be useful when we are trying to solve an equation and we want to solve it with square roots. We can complete the square on one side, and then we can take the square root of both sides to solve it. So if we look at the other problem, x squared plus 8x equals 33. Someone has the answers here, but I'm not really sure how they got them. So this one we'll go ahead and do together. So let me go to my slide right here. So if you look at our equation, if you just look at the left-hand side, over here we have x squared plus 8x. So this is a binomial that if I add an extra term in, I could complete the square and set it up so that we can solve it. And so I look at what's in front of the x term, which is 8, and I'm going to use that 8 to figure out what number I should add. Okay. In parentheses, I'm going to take 8, divide it by 2, and then I'm going to be squaring that. Eight divided by 2 is going to give me 4. We're going to divide before you square. And 4 squared will give me 16.
Good afternoon, Titans, and happy.
Plus 8x is there. Now we're going to add 16 to the left. And that completes the square on the left-hand side. But because we add 16 to the left, we have to keep our equation in balance. So we're going to also add 16 to the right. And then from this step here, we can now, because x squared plus 8x plus 16 is a perfect square trinomial, we can write it as the product of the same binomial. So the way you figure that out is you look at what did you square here? We squared x. So the first term in the parentheses is x. We have addition both times. So we're going to put a plus. And then we want to put what we squared for the constant term. So 16, the square root of it is just, we're going to put the positive 4. And then this is all being squared. It's to the second power. And then we're going to simplify the right-hand side. 33 plus 16. with that one. All right, so we completed the square and we rewrote it. So now this looks like something we were solving on Monday and Tuesday. And I just want to show you that it is true that x plus 4 times x plus 4 will give us back x squared plus 8x plus 16. So just kind of like off to the side, I'm just going to show you that that does work. You have x plus 4 times x plus 4. And if you're just checking to see if this is true, you would just FOIL it to see that it does work. So your first terms for x and x gives you x squared. I don't exactly remember the color order here. The outside terms are, we have plus 4x, and then the inside terms plus 4x, and then the last terms, which is plus 16. And so you can see that we really do get x squared plus 8x because 4x plus 4x is 8x. Okay, and so we were just kind of undoing that with this because it is a perfect square trinomial. We're able to write it this way. But now what we're going to do is what we were doing earlier this week is we're going to take the square root of both sides. Okay, and when I take the square root of x plus 4 squared, they're like inverse operations. They cancel each other out. So I'm just left with x plus 4 equals. And this is where we have to put in that plus minus symbol. And the square root of 49, that's a perfect square, so it's 7. Then we can take this and solve the two equations that pop up. Okay, one equation is x plus 4 equals positive 7. The other equation we get is x plus 4 equals negative 7. So it's one of these values of x. That's the solution. We're going to solve each equation using inverse operations. Subtract 4 from both sides. And so x equals 3, or x equals negative 11. All right, if you guys have questions on that, long time to spend on a warm-up. We still have 20 minutes, but we only have 2 slides left. I do want to go backwards though with you because I looked at your work from yesterday. I didn't find any correct answers on the practice on your own. So I'm going to go backwards and do that problem with you as well. It's very similar to this problem here because of just the way it's set up. So I'm going to go ahead and move back one to this equation. X squared minus 10x equals 11. And so to solve this equation, we want to complete the square, which means I need to figure out what b is. And then from that value of b, I'm going to add it to both sides. So we're going to look here. We have negative 10. And so we're going to use that and put it in parentheses. Divide it by 2. And then we're going to square that amount. which PEMDAS order says to, and you can't see this yet, there you go. PEMDAS order says to do what's in the parentheses first. So we want to take -10 and divide it by 2 first. That'll give us -5. I'm going to keep those parentheses up because -5 is what I need to square. I don't want to square just 5, I want to square -5. And that's the difference between having parentheses around -5 or not. That 2, that exponent of a 2 belongs to the very first thing it touches. If it touches the parentheses, then it belongs to everything in the parentheses. But -5 squared is -5 times -5, so I get 25. So that tells me what to add to both sides of this equation. I'm just going to kind of move that over there. I'm going to use pen tool here, so x squared minus 10x, and so we're going to add 25. This is going to complete the square, so I can factor it. And then we have 11 on the other side, which I need to also add 25 to this side. Keeps it in balance. And so when you are trying to factor a perfect square trinomial, you can go back to this slide, slide 3, which I've changed, so this example's gone now because it was totally messed up. You know, what form do I have? Is it where I'm adding the middle term or I'm subtracting? So the problem I'm on right now, we're subtracting this middle term. And so, I wish I could like just copy and paste it, but it's not letting me do that. We have a squared, all right, and b squared. And so what I need to put in the parentheses is what is it that's here that's being squared and what's being squared here. So basically you take the square root of whatever this term is and the square root of whatever this term is, and then you can put it in here singular, a plus b. So like the square root of x squared is just x. And then we have the subtraction sign. And the square root of 25 is 5. Okay, and then that binomial is squared. And you can always check that this actually does equal what you have. You come over here and just write it out, x minus 5 times x minus 5. And you FOIL it. First terms give you x squared. The outside terms give you -5x. The inside terms give you -5x. And then the last terms give you positive 25. Okay, and you can see that this does simplify to what we want it to. This is just kind of like checking that it actually works. And then 11 plus 25 is going to be 36. This is where we're going to now take the square root of both sides. So x minus 5 is equal to positive negative square root of 36. And you can break this into 2 equations. X minus 5 is equal to positive square root of 36, or 6. And then the other side, we get x minus 5 is equal to negative square root of 36, or -6. You want to solve both equations. So x is equal to 11, or adding 5 to both sides here, x would be equal to -1. Okay, so Ask questions if you want me to clarify something. Isai, you're living in a house built in the 1700s. You're funny. But no, AC is not fun though. Not right now. Way hot. So does that make sense? You guys have questions? Like, you can ask me on the chat. You can ask me through GoGuardian. Because we're going to look at a different situation. So right here, when we were looking at the steps yesterday, we were just starting on step 3. And that's what we just did. The last 2 problems we've done, we started on step 3, where you complete the square on the left side of the equation and balance this by adding the same value to the right side of the equation. But we're going to look at what happens when the coefficient of your x squared term is not 1. How do we do that? And so that's the next example. So here, the coefficient of our x squared term is 1/2, and we want it to be 1. So to eliminate that, what we're going to do is, you could think of it as dividing by the same thing. We're dividing every term by 1/2, or you can think of that as multiplying each term by 2. Okay. So we're going to multiply this entire equation through, let's say, or divide, depending on what number you have there. If it was a whole number, you would divide everything by that whole number. If you have a fraction, you would multiply by the reciprocal. And so that's going to change the value of this. So right here, I'm going to basically multiply this term by 2. I'm going to multiply this term by 2 and this term by 2. And so because I'm doing the same thing to each term, it doesn't change the value of anything, but now this gives me an equation that's like the other ones we were working with. We now have x squared, because these 2's cancel, plus 2 times 4 is 8x, and 2 times 10 is 20. And then we're going to use the coefficient of the x term, which is called b, but that's kind of arbitrary. It is b, but we use that to divide it by 2 and then square it so that we can complete the square. Which is 4 to the second power. Which is just 16. Okay, so then we're going to add 16 to both sides, which completes the square and sets it up so that we can solve this equation. Make sure you add it to both sides to keep both sides in balance. Okay, so what am I going to put in here? What numbers are going to go there? I know we're a bit limited on time, but I'm going to give you like a minute here to figure that out, or two. You can tell me in the chat. You can show me on your slide. What would I put in the parentheses? What am I adding together? So I could kind of see your work. Adding 16 to both sides. What's going to go in the parentheses? 20 and 16? No. So remember, it's what you're squaring to get x squared and what you're squaring to get 16. We squared x to get x squared, so x goes here. We squared 4 to get 16, so 4 goes here. And you can always come over here and like check that that actually works. Okay, so it does check out, which means we're ready to go and take the square root of both sides. Okay, so now we have two equations that are going to get set up from this. Two scenarios. We either have x plus 4 equals positive 6, or x plus 4 equals negative 6. So go ahead and solve those. What does x gonna equal on each of them? See if you can finish this. So let's see, what are our two possible answers here? For this side, x could be what? So we don't have it yet. We're just going to solve each equation using inverse operations. Subtract 4, subtract 4. 6 take away 4, it's 2. Over here, subtract 4, subtract 4. Negative 6 minus 4 is negative 10. Okay, so we have about 4 minutes left. There's one slide left for you to do. And I'm going to put you on student pace. And you're going to try this one on your own. X squared equals 14x. I'm sorry, x squared minus 14x equals 95. I'll just leave my screen here in case you're still looking at that and finishing it.